Okay, so we're moving into factoring, which is kind of the opposite of what we did for the last several lessons. So we'll start with a good old-fashioned GCF, greatest common factor. A factor is a number or expression that divides evenly into another number or expression with no remainder. Number expressions that multiply to another number or expression. It's basically what you multiply to get numbers or expressions. Greatest common factor, the largest possible integer of a polynomial that divides into a given set of terms without a remainder. So what are the greatest common factors of 50 and CY? We look at the numbers. What goes into both 50 and 15? 5. There's not a C in both of them. There's not an A in both of them, but there is a Y. So 5Y. The greatest common factor in 8b squared Z and 24b Z squared. You should try this one. Pause it here and check your answer. Okay, so try the 8b squared Z and 24b Z squared. Okay, I can take out an 8 out of both of those. Between b squared and b, the most I can take out of both of them is a single b. Z and Z squared, the most I can take out of both of them is Z. So just 8bZ. Now, let's apply this to expressions. We're going to factor a polynomial. Factoring an expression with a GCF. Sorry, the process of breaking down a complex polynomial into a product of simpler polynomial factors. You're essentially, when you're factoring an expression with the greatest common factor, is essentially reversing the distribution process. So, what goes into both 4a squared and 8a? Well, they're both, we're going to do this divisible by 4. And I've got 2a's here and 1a, so the most I can take out of both of them is a single. So that goes on the outside, and then you do this division. 4 divided by 4 is 1. A squared divided by a is just a. Bring down the plus. 8 divided by 4 is 2. A divided by a is just 1. We don't need it. So it's 4a times a plus 2. And the idea is, if I distribute this back in here, I get this. We're undoing distribution. We'll work one more together. What goes into both 12 and 9? 3. That was a terrible 3. I apologize. Not much better. I've got 3 x's here, or x cubed here, and 1x here. The most I can take out of both of them is x. So 3x goes on the outside. 12 divided by 3 is 4. X cubed divided by x is x squared. Plus 9 divided by 3 is 3. X divided by x is 1. And again, I would get 12x cubed plus 9x. Okay, you try these last two and come back and check your answers. Okay, the common thing between 6 and 2 is 2. X squared and x, I can take an x. I only have a y in that one. So I put 2x on the outside. 6 divided by 2 is 3. X squared divided by x is x. Y divided by 1 essentially is y. And 2x divided by 2x is 1. And the whole point is I should be able to do this and get what I started with, which it is. Okay, 8 and 12 is going to be 4. And then a squared and a, I can take an a from both of them. B and b squared, I can take a b from both of them. So 4ab. 8 divided by 4 is 2. A squared divided by a is a. B divided by b is 1. 12 divided by 4 is 3. A divided by a is 1. B squared divided by b is b. And the whole point is there should be also nothing left for me to be able to factor out again. There's nothing in common between 2a and 3b. Okay, let's get some trickier ones. Here I got no numbers. I've got x to the fifth and x squared. Most I can take out is x squared. Y to the fourth and y to the third. Most I can take out is y to the third. So that goes on the outside. X to the fifth divided by x squared is x to the third. Y to the fourth divided by y to the third is y. X squared divided by x squared is 1. Y cubed by y cubed is 1. And there we go. Nothing left to factor out. Okay, you try these last two. Come back and check your answers. All right, so if you're not sure what goes into both 15 and 34, if you do 51 and 34, it's not always the case that the difference is the one number that goes into both, but it will be the biggest number that could go into both. It won't always be the one, but you can start there and work your way down. It just so happens that 17 works for both of them. So we'll use 17, and I can take out a C and a D. So 17, C, I meant to do that. 51 divided by 17 is 3. C to the third divided by C is C squared. D squared divided by D is D. 34 divided by 17 is 2. C divided by C is 1. D divided by D is 1. There we go. Okay, this one, some people want to divide out negative 12. You can. We're going to start with just dividing out 12. I'll show you both ways of this. And I've got x to the fourth. Let's put 12 over here. I've got x to the fourth and x squared. Y and y to the third. Z squared and z to the third, so I can take out z squared. Negative 12 divided by, we'll put that on the outside. 12 x squared y z squared. Why do I need that parentheses? Parentheses here. Negative 12 divided by negative 12 is negative 1. X squared divided by x squared, y divided by y, z squared divided by z squared. All of that is just 1. 48 divided by 12 is 4. X to the fourth divided by x squared. Y to the third divided by y. Z to the third divided by z squared. Now, what would happen if I had divided by negative 12? Well, then this would be negative 12, still x squared, y, z squared. The only things that are going to change are the numbers. Negative 12 divided by negative 12 is 1. Everything else still is 1 as well. Negative 48 divided by negative 12 is positive 4, x squared, y squared, z. Either of those is an acceptable answer. Delta Math accepts both, and this comes down to when we start using this in solving equations, you just use whichever one makes solving easier for you, quite honestly. It makes you do other factoring that will come up later. Okay, there you go. Good luck.